Hi, this is Team 4. We're going to present the proposal, Improved CelebA dataset via debiasing process. Our team started to explore that machine learning algorithm can discriminate based on gender. We got an idea from this paper, Gender Shade. This study evaluates bias present in 3 commercial face analysis algorithms, including IBM, Microsoft, and Face++. This study includes images of 3 African countries and 3 European countries. The results show that all companies perform worse on darker females. IBM had the largest gap in the accuracy, with a difference of 34% in error rates between lighter males and darker females. As our research topic lies in gender bias in computer vision, we've picked 2 relevant works. The second paper here tries to resolve the gender bias problem through the algorithm. They show even the balanced dataset does not perfectly cut out the relationship between object and gender. However, they deal COCO dataset and IMSI2 dataset, which are composed of the object and actions. As our target dataset is CelebA, which is composed of the face, we conclude that balancing the data is still meaningful for the CelebA datasets, since the feature of COCO dataset and CelebA is different. This is our replication approach. We'll replicate 2 papers. First, Gender Shade. We'll develop a FaceNet model and train the model with the CelebA dataset. Gender shades evaluate the commercial face recognition model. We cannot fully replicate the exactly same model as this paper utilized. Therefore, we choose to replicate the FaceNet to find a bias as the paper does. Second, as a benchmark to mitigate the existing biases in CelebA dataset, we'll utilize inclusive FaceNet. Based on the limitation of this paper, we suggest the alternative solution for the better face attribution detection. To improve face attribute detection accuracy, inclusive FaceNet focused on providing the images, gender, and race information. However, it has a limitation. First, since inclusive FaceNet utilizes the information from given training dataset, it cannot achieve better performance with the imbalanced or biased dataset. In such dataset, the images in certain classes cannot fully represent its class. For example, let's say that long hair class in facial image dataset contains only female image. Then although the length of the hair is not related to the gender, it is possible for the face attribute classifier to learn that correlation between female and long hair. When the classifiers additionally get the gender information of the image during the training, the bias may get even worse. In this case, the trained model would be more likely to classify female images as long hair class. Therefore, we present an alternate way to improve face attribute detection accuracy through the debiasing dataset. We first find certain classes in CelebA that cannot represent itself and debiase the classes using the various data augmentation technique. To be specific, we are planning to use the image-to-image translation models Stargan version 2, which can translate a specific facial attribute of an image to another. For example, if the long hair class lacks male image, we can translate female image with the long hair to male image with the long hair, and then add the images to the training dataset. Furthermore, we will try other data augmentation techniques such as oversampling, color jittering, and etc. To evaluate this method, we'll compare the classification performance between inclusive FaceNet and FaceNet trained with our augmented dataset. Also, we'll compare various data augmentation methods to find the most useful or helpful technique to elevate a gender bias. We'll use the CelebA at first, which is because it's utilized in the inclusive FaceNet paper. CelebA dataset contains 200,000 celebrity images with 40 face attribute annotation. If we had enough time, we also tried the LFW or PGG FaceNet dataset. And finally, this is our weekly plan. First, we'll work on a bias detection, referencing the paper we mentioned before for about 3 weeks, and then devise the dataset with various data augmentation technique for other next 3 weeks. We're going to learn by the we're going to focus on starting version 2, then try the other technique that seems most useful and helpful. And lastly, we'll analyze the result and compare the performance of the technique with the original method for other 2 weeks. And thank you.